The separation method number 3 that we are going to discuss about is fractional, is distillation. So this is distillation. Distillation is a fractional method that is used in miscible solutions. So let us say we want to separate salt from water. So we all know that salt totally dissolves in water. So this is a salt water solution. So to separate these two, the solution is a dissolved solution. Salt totally dissolves in water. Now we want to separate the two, so we employ a method that is called distillation. And this is a distillation apparatus setup. So what happens is we apply fire to the solution, and this solution will reach a boiling point. And when this solution reaches a boiling point, water is going to leave, and this is the easy route out. So from this point, when water starts to boil and it leaves in form of steam, it will be a gas. Up to this point, water will be in form of gas. The distillation apparatus is attached with a condensing apparatus. So this condensing apparatus works in a very simple way. There will be water that is being pumped into the condensing apparatus and pumped out. It goes out. So this water will be cold water. So because this water will be cold water, this steam that is escaping, this gas that is escaping, when it reaches inside the condensing apparatus, it is condensed because it will meet a cold temperature. And when it meets a cold temperature, it loses its kinetic energy. So the kinetic energy is lost, and the forces of attraction increase between the particles of the water. When the forces of attraction increase between the particles of water, they get together, and the water becomes liquid again. And as the water becomes liquid again through the process of condensing, it is collected in the beaker. The salt, when all the water vapor in form of gas boils out of this apparatus, the salt will remain. This is distillation. But we, however, have fractional distillation. Now, the difference between distillation and fractional distillation is that in fractional distillation, is a separation method that is used to separate miscible liquids. Miscible liquids are liquids that totally dissolve in each other, and they have a similar density. Their density is almost the same. So let's take, for example, ethanol and water. Ethanol and water is mixed, and now we are going to do what we call fractional distillation. So these two liquids are totally dissolved into each other. You cannot tell that this is a solution. But however, these two liquids have got different boiling points. Ethanol boils at 78 degrees Celsius and water boils at 100 degrees Celsius. So that is where the name fractional distillation comes from. The boiling points are fractional, they are not the same. So the ethanol and water solution is heated. So now that we know that ethanol boils at 78 degrees Celsius, we gradually increase the temperature of our heat until 78 degrees Celsius. When we reach the temperature of 78 degrees Celsius, ethanol will turn from liquid into gas. So the particles of ethanol increasingly gain kinetic energy, and at 78 degrees Celsius, they turn from liquid into a gas. They will escape in form of gas from the water particles, and they will take, this is the path that is easy to escape from. Now, when they take that path, and when they reach the condensing apparatus, they meet a cold temperature. So still our water is being pumped in there and pumped out there. So this water is cold. So as the ethanol particles escape from this apparatus, when they reach the condensing apparatus, they meet a cold temperature, and then they lose their kinetic energy in this apparatus, and the forces of attraction between them increases, thereby condensing, and they attend from being a gas state into being a liquid state, and we collect our ethanol first. When we realize that there is no more boiling that is happening while maintaining our temperature at 78 degrees Celsius, at that moment it means that all our ethanol is boiled out and it is collected in our beaker. We then need to increase the temperature, the heating temperature, to 100 degrees Celsius. So when our thermometer reads 100 degrees Celsius, there is our thermometer. Our water will also start to boil. And obviously we would have removed the ethanol that we collected in the first beaker and put another collecting beaker. We maintain the temperature at 100 degrees Celsius, and all our water will boil out. So the same process, water will boil out and it will be condensed in the condensation apparatus. So as it meets a cold temperature, the kinetic energy of the water particles is lost, and the forces of attraction between the particles are more, and the particles get together and they become liquid again. In fractional distillation, a certain temperature must be maintained until the substances that boil at that temperature have all boiled. That is very important in fractional distillation. Now, fractional distillation has been industrialized, and it is the same method of separation that is done by scientists and engineers in the manufacture of diesel and petrol. So, diesel and petrol come from crude oil. Now, this is what we call a fractionating column. So, when they are making diesel and petrol, they use what we call a fractionating column. Sorry, there's an O missing there. You must understand that this is an industrial process, but it uses the principle of distillation. But this is very, very heavy industry. Now, diesel and petrol is extracted from crude oil. So what happens is crude oil is burnt, until it reaches a temperature of 450 degrees Celsius. So at a temperature of 450 degrees Celsius, the crude oil is pumped into a fractionating column. Now, at a temperature of 250 degrees Celsius, near the bottom of the fractionating column, diesel is collected. And at a temperature at about 25 degrees Celsius or less, way above the fractionating column, petrol is collected. Okay, now we need to understand the reason why diesel is collected at the bottom at this temperature, while petrol is collected at the top of the fractionating column at that temperature. Now, in diesel, every molecule of diesel contains about 13 to 19 atoms of carbon. And every petrol molecule contains about 5 to 10 atoms of carbon. Then that means that the particles of diesel or the molecules of diesel are more dense. In other words, they are more heavier than the molecules of petrol. So, because the molecules of diesel are more heavier than the molecules of petrol, that makes them not to be able to rise way up in the fractionating column. They occupy the bottom space, the molecules of diesel. This is the reason why diesel is able to be collected at the bottom of the fractionating column. Petrol, on the other hand, the petrol molecules have got about 5 to 10 carbon atoms. Therefore, petrol is lighter than diesel. So, it has got a tendency of rising up in the fractionating column. That is why petrol is collected high there. And for the same reason, that is why you find that diesel will have more energy. It is because diesel is more dense than petrol. Diesel contains more carbon than petrol. And diesel will obviously have more energy than petrol. And from here, we are going to discuss the last two separation methods: separation by evaporation and separation by use of a separation funnel.